Yeah. So, object-oriented programming. Does anyone know anything about it? Maybe Ricardo? No?
Yes, I'm very familiar with that.
Great. Please run this lesson for us.
Okay, let me take over.
I will just change slides and you will just talk about that. So yeah, OP is the same, the pattern is the same, it's just like an approach in programming. And we will talk about that, but this is just a philosophy, I would say, in programming. So that is why if you worked with OP in any language, you understand basically that very well. So yeah, that is why Ricardo can run our lesson today. And I believe you're familiar from PHP, right?
Yes.
Yeah. Okay. Do you do that a lot?
Well, it's very important whenever you came to work with overall frameworks. So to deal with any framework, it's very important to understand the concepts. Now, most of the people in PHP don't actually use it as much as in other languages. Like, for example, when you're doing any, let's say, C# or C++ thing, it's most commonly used. For the web, it is really helpful whenever you're building like bigger web applications, but for the regular day-to-day stuff or minor things, it's not that very often used.
Okay. Yeah. So I'm not like a big expert in OOP because I'm not working on daily basis. And as I said, I've changed like 6 companies and I haven't seen OOP in any. And it just some companies still doing something with OP, but yeah. Okay.
In PHP world, whenever you go to a framework, let's say Laravel, for example, is probably the most used one. You need to know all the ins and outs of the concepts of object-oriented programming, or you just won't get how the framework works. So from that perspective, it is really important in PHP if you are not going to be if you're going to be working with a framework.
Okay. Cool. So let's start. If I'm saying something wrong, Ricardo, you can just correct me if I miss something.
Right. Thank you.
So basically everything organized around objects. So you creating classes. We call classes our objects. We will call classes, and instances. Instances mean that you create a class which is kind of like a blueprint, like an instruction, and instance, it means that you create one thing with one instance, one copy of that class. So you took the blueprint, your class, pass some data to get to initialize, for example, a user, if you have a class for user, for example. And so it, again, the whole object, why it's object-oriented programming, because it basically around the actual, you creating things like actual objects in real life. So if you can create like an object, a car, and you will give properties with I don't know, windows, wheels, engine size, fuel consumption, etc. So you creating an object, an instance of that. Like I will show you these examples in a second. And as Ricardo said, improves organization. So that means that when you have a huge applications, some people still use OP because they want to have the organized hierarchy and the structure for their applications. So basically the new syntax, so to create a class, what you do is just class, for example, book, right? and you can create a book, class book basically. And let me just think. So what do we want to have? We want to have constructor, and we will pass. So when you instantiate the class, you will pass a variable, which is a name in our case, and maybe we want to pass author, and we will store it in our class with a name, and we want to have our name. This is the basic syntax for the class, and this, so you use this basically, author equals author, right? So you created a class. This is your blueprint, and now you can create instances of that class. So let me create it, open terminal. We're in the lesson, beautiful. So let me just create a new instance, const, I don't know. Any suggestions on the book? Harry Potter. So to create an instance, somebody doesn't like classes, I can hear. We can talk about anything else. So to create an instance of this class, all you need to do is just new and book. And here, it is expecting your two parameters. So you need to pass two parameters. I don't know. Let's rename it favorite book. And let's, why is it spelling? Do I have, yeah, favorite book. So Harry Potter, to be honest, I don't like this Harry book, but yeah. Harry Potter, and is it John Rowling or?
J.K.
Yeah, I think
Rowling.
it's J.K. Rowling, yeah.
J.K. Rowling. Like this?
Yeah.
Yeah,
I think
beautiful.
it's .lu, but that's fine.
So now we've created an instance of the book. So now if I try to console log favorite book, let's run it in Node. So we have a class, right? It looks like an object, right? And you can try to do dot name. You have Harry Potter, right? So this is basically like an object, but it's not just a simple object, because you can create different classes, like get name class, which will basically what it does. You can write any logic, but normally based on the name, get name will return this dot name, right? So now you can call get name, execute this, and you will get your Harry Potter, right? Or maybe you can do set name and pass a new name, and you will do this dot name will be, let's rename it just new name, will be new name, right? So that will be a way to set the new name. So what you can do here is just favorite book dot set name and new name, book name. Save. So now we just redefine it, right? So this is how the class, because you created a class, and now you can create many instances of it. You can create const second favorite book and create a new instance, new book, and maybe, I don't know, something like that. And not John Rowling. Can you remind me who is the author? Come on.
Pass on that.
Tom. Gosh. Twain. Yeah.
Mark Twain.
Yeah, Mark Twain. Mark. Yep. So you created the second one, and basically the same thing. So you have the full functionality from here, but for this book now. So you're creating instances. You're not modifying the initial object. So this is a difference, right? So it looks like an object, but you can create a new instance of that object with all the functionality. And you can create like a calculator class, which will have add, subtract, multiply, whatever you want. And you will have this instance, like a new you will create new calculator, and you will have a new instance with the value. Or you can create, for example, maybe that will be as well useful. Give me a second. So here, if I save, we have Tom Sawyer, right, for the second instance. Also, yeah, so this is the basic class. Let's leave it for now. Let's move further. And here we have like 4 principles, which is encapsulation, abstraction, inheritance, and polymorphism. So encapsulation means that you have basically you have internal data. You can keep internal data inside your class and instance of the class. So what it means that, for example, let's go to our, I don't know, budget or wallet. Let's create class wallet. Let me think, what do we want to have? Constructor, say, potentially we want to have we potentially don't want to take anything. This is a brand new wallet, so we will start from this value, or value equals 0, right? So this is my brand new wallet, and I will create a few functions like add to wallet. I know, total, good variable name, money, just money, value. And here I will do this dot value plus equals money value, right? Plus equal money value, right? Or we can just subtract from wallet, and we will have something like this, value, this one, right? And we will have another, again, function just to get value, which will return this value. So just a wallet. And let's create my wallet variable, which is new wallet. So you just initialized a new wallet. Console log my wallet dot get value. To get the value is 0, right? Set times. So what we can do, let's say add some money to my wallet. So my wallet, add to wallet, and let's say, I don't know, 10. So now we have the value is 10, right? But I can create another wallet, const another wallet, which is again new wallet, and the value for that wallet will be 0, because this is a new instance of your class. So if you copy this, save, we have 0, right? So let me just show it to you, that another wallet, and for this one we have and this one, save. Yep, so my wallet 10, another wallet is the 0. So I can call the function for another wallet and add 50, for example. Save. We just move it down, just here. And we have two wallets. So we create separate instances of our class, right? So we can create in kind of reusable functionality with the memory. And you can get the value from there and you can work with that memory. Does it make sense?
Yeah, but you don't change on the class, you don't change the value.
So you're just doing actions here. So you're doing like plus equals, right?
Right.
Or minus equals. So you kind of changing. So encapsulation means that you have value here and this is available inside your class.
Okay, it's almost like a default value for the next.
Yes. Yeah, so this one is the default value for new instance of the class. You're talking about this value, right?
Yeah.
Yeah. Yeah, so this is just a default value. You declare a default value. Yeah. So you can create basically things. You can when you initialize your new class, you can pass a few things, store it in your instance, and then you can get these values later based by using some methods on the class. So this is encapsulation basically. Yeah, and you interacting as we did with our wallet. You just modifying inside. You can have something like if you have a class person, and you can have happy birthday method. So when you call it, you will just change the attribute of this person. The age will be current age plus 1, right? So you just again. You have like an object is the person with a name, age, race, I don't know, city, etc. And you can work with this data. You can create new instances of users and have them and work with them. Okay, so yeah, here another thing. So you can. This is just another logic. We have things like private and public. So public means that you can call things from like we did, like here, at the wallet. And we can call this function directly. But if you have private, that will be can accessible only from inside. So if I try to use, for example, let's do for subtract private. Hey, what's going on? Private. Ooh, what's going on? Right. No. Let me check that. Why my private? Yeah. Ooh, sorry. Private. Let me just double quick check that. Not that. This is odd. It might. Oh, hash. Okay, so they use hash now. Okay, yeah, fair enough. So if you use hash, right? I'll change before starting. Expected token. What's going on? Sorry. Let me just double check. Private method looks fine for me. Why it's complaining? What's going on? I know what's going on. This is Node.js and we should do that in the front end. Sorry, my bad. So index HTML. Right. It's so easy to switch between languages. and forget about the syntax. src index.js. So open index.html. Yeah. So now we have two methods, right? And we have our so basically my wallet. If I have my wallet, we have function subtract. So let me try dot subtract from wallet 10. See, it's not a function, so you can't access actually to it because it's internal, but you can use it here. I don't know, -5, -10, for example. Refresh. Wait a second. Get value. Oh, look at that. Subtract from value is not defined. How did they change it? Sorry, I definitely need to check this because I haven't seen their new syntax. Is it like that? We have static private field. Okay. I think, and the method search static. So what do they use? Okay, let me check. So now you can use. Can you use? No, you can't. Just this. Yeah, I think like that. Yep. So now that should be valid. Yeah. So see that here, if you try to use directly, it's not valid because it's private, but you can still access from get value, right? So you can actually, this is how you create private methods on your, inside your class. Oh, sorry.
Would you have private methods?
Sorry?
Why would you bother and have like private methods?
For example, you want to, you have some data that needs to be set only once, right? Maybe, for example. Give me a second. Sorry, I lost my slides.
Let me give you an example on that one. I think it was Thomas, the one who asked.
Yeah.
Okay. Remember that object-oriented programming, it's first of all, it's a paradigm, I think it's mentioned in English.
Yeah.
And it brings some things that you might initially consider like unneeded. Like if I need a code, why does it matter if I hide it, for example? I just want the code to run. So you might not get the value of the benefits of it right away. But whenever you program with it, you take control over many aspects of it. So let me give you a real example. You're coding for a bank. You do not want any procedure out of a specific file to change the balance of a client, for example. So that particular file might be like just very few people have access to make changes on that file because you are allowed to make those sort of changes. So you make a function private, meaning that if you need to troubleshoot what is going on with the balance of a client, that's the only file where that can happen. So if somebody else hack it, for example, from an external file, you cannot have access to the method that actually changed the balance because it's private to that specific functionality in that file. So this, like I said, I mean, that example you're coding for a bank, you are not just doing like any simple application like we are doing at the moment. but that's where the concept applies, so that you control that nothing out of that file it's allowed to change anything on that file.
Got it. Thank you, Ricardo.
Yeah, thank you. So yeah, basically you might sometimes you want to have accessible logic outside the classes. Sometimes you might think that I don't want to make it accessible, and that should be just internal for some internal manipulation, let's say. Or maybe sometimes you want to you can create inside you can create a method that should be run only with two other methods. So you don't want to make them available separately, you want to run them all together. So you create in like a private, as we did here, you create a private logic, and on some other function you do this and that, because both should be run. Otherwise you don't want to make somebody else to run only separately, they sing separately. Yeah? Okay, great. So yeah, so you create, this is what I just showed you, so you just create new person. Sorry?
We can't see the presentation anymore, I don't think.
Oh, thank you. Yep. Can you see it now?
Yeah, thank you.
Yeah, cool. Yeah, so this is what I showed you. Oh, sorry, so you didn't see the screen. So yeah, I was showing you that sometimes you want to run in as a group of actions, right? And you don't want, for example, you don't want to do subtract only separately, you want to have it in sequence with something else. That is why you wrap it into something and you run as three functions inside. So you know that all of three actions will be triggered and you don't want to make somebody else to trigger only one action. So yeah, this is another reason.
Right, okay.
Yeah, so you creating a class and you invoking things, right? And here not allowed because this one is private, right? That is why you're not allowed. Questions on encapsulation? No?
Not for me, no thank you.
Okay. So the next stop for us is abstraction. So basically you're hiding implementation. You're creating some logic inside that is not accessible from outside your class. This is what, yeah, so let me again. So yeah, program can be huge, object interacting with objects to infinite and beyond. So you can, yeah, you can build a structure, and I'll show you I think in the next slide. But yeah, you can build interaction between classes, etc. Exposed methods should be clear and high level. So the classes that you might make public, they need to, it shouldn't go very deep into your logic. You need to, this is abstraction. So again, this is what I've showed you here, that you might have a sequence of steps to do some action that will be public. That is why you create in this abstraction, which will do a sequence of things to actually achieve the goal of the abstraction. So that is why you create in these abstractions. Yeah, and classes should be self-contained, which means that the class by itself, but based on the name, you creating the method that's relevant and the like data inside the variables, the attributes relevant to that class. Right. So here we have class menu and we have button 1, button 2, active, false, animation time 1000 milliseconds. All of them are public. So here, Sam's create. You don't know Sam, but so you initializing the menu, and you can set something to our buttons, and you can set timeout based on menu timeout, right? So it's not very abstract. You like specifically interacting with every single property, right? You directly changing something for button 1, button 2, changing this and setting the timeout. So this is not very abstract. What you can do is you have a sequence of things, you have a few things that you want to change, and that is why you create in an abstraction, like a method, that when you call this method activate, it will change this, this, and that, right? This is what I'm saying. When you, and all of these are private because you don't want to expose it to the whole world. You just, you will set it to these values, but as a group of something. That is why you create an abstraction, which is basically a wrapper with a name, right? So this is another method that will change a few things. Yeah, that makes sense?
Yep.
Okay. Yeah, so we actually, so here we have another thing that now you're invoking activate, and yeah, so here we have a poll. Sorry, it's not a very nice slide, to be honest. Let me just quickly fix alignment. Yeah, so the move
Hello?
here, yeah, can you hear me? Hello? Thomas?
Yes, I can hear you.
Okay. Yeah, so again, for example, if you want to move, it's not in this move, you have a few things that you want to change inside your class for this instance. And that is why you make it public, but you do a lot of, quite a few actions. Hello, Thomas. Today is the evening of technical issues. Can you hear us? Can you hear us? Sorry, guys. No? Oh my gosh, what's going on today? Okay, he will rejoin. So, yeah, basically we just create an abstraction around it.
So why do you need to create the wrapper or the abstraction?
So again, because you want to have change, if you want to change a few things, right? You don't want to do that separately, and you don't want to allow other people to do it separately.
Mm-hmm.
You want to have a sequence of something all together every time. That is why you create another function, like we did here, or maybe on the previous slide. We had this one, not this one, this one. So we created a method, and inside this method we have just a few things that we want to change. We don't want to change just this or just this, because if you expose them, great. Sorry, Thomas says it. I'm not sure what's going on. Can't hear anyone. Yeah, right. Sorry. Is it? So yeah, that is why you basically, because somebody, if you make all of them public, somebody can just change this one, just one, and that will break your application, right? Or change just this one. That is why you want to make group of things private, and then if somebody wants to make active button active, then they need to call the function, and that will do all of them.
Okay.
That is basically, the abstraction is another word for a wrapper of your for the function. Let's say you just take a few things, wrap it into the function, and do it all together.
Cool. It's like you done on the code when you wrote it.
Yeah. So
yeah, I get it.
I would say that here, for example, you have const at value. Let's say you have a function at value, and you have total, and you have value, and you have return term total plus value. And then you have something like const I don't know, so add to receive, let's say, yeah, receive money. Come on, sorry guys, receive, oh my gosh, receive money, which will take just value. Actually not just value, it should return value. So that will, let's say in our case, return, I know, 50. And when we call, we can, so abstraction in programming is not about just OP, just a random thing that you're wrapping into something into it. So if you create a function const add to wallet, and we will call, for example, a receive money, const money. We will call this function, and then we will call add value. Let's say add value, we will call this. With total, we need to have some total. Let's say, I don't know, 5, and money, the new value, the money that we want to add. So our add to wallet is an abstraction.
Mm-hmm.
Thomas?
Oh, hi. I'm on my phone now. The screen is getting smaller and smaller.
So next time is Apple Watch, right?
Exactly.
This is really funny. You can try to join on the phone too, so we can hear you, and on your computer so you can see it.
That's actually a good idea. Yeah, I'll try and do that.
Mm-hmm.
Yeah.
Yeah, so now your add to wallet is an abstraction for these two things, right?
Mm-hmm.
It's still a function, but we just give another name because we like names and different names. So, because if we create and call the same thing in different names, normally normal people will pay us more because they are more confused. So this is the goal: confuse our clients so we can charge more. Because it's too complicated to understand. This is the same approach we have as lawyers. Trust me, I know that. This is just an abstraction. That is why we call abstraction. Okay. Thomas, can you still hear us?
Yeah, I'm actually still on my phone.
Yeah, I'm just I want to continue, so that is why I'm asking.
Yeah, sure. Please continue. Yeah, sorry about
Okay. Yeah. Okay. So, any questions about abstractions? No? Okay. Okay. So, another thing is inheritance in OP. So we have basically we have the way that allows us to create a new class by using existing one. So you can create basically you have a very generic one, and you can create something more specific, right? So for example, you can create the class car with like a very generic things like for example, I don't know, the speed, the name, and this is it pretty much. But you can create a class, I don't know, BMW, which will inherit your class car, plus will add a few things. Yeah, so for us, let's actually say let's go back here. Let's create class car cat car with constructor, and that will have name, and we will have something like this: speed equals 0, and potentially this name equals name as we're passing, and this engine size equals 0, for example. So we can have drive with speed, this speed will be speed, right? So when we call this car, this method in this car, we need to pass speed, and that will change this current speed for this in this instance. And let's say console log, we are driving with let me just use interpolation. Oh my gosh, sorry. So we are driving with this speed, or maybe with speed 6, I don't know, something miles per hour. Yep, something like that. So now, for example, we can create another class, I don't know, BMW, and here we want to have everything from this class. So all this functionality, crazy functionality, of course, but we want to inherit this because this one is very generic. So what you can do is just do extends car. So you're extending your BMW with class car, so you can have everything from car plus something specific for this class BMW. So let's say let's create a class, for example, I'm just thinking Go, right? And that will do what that will do. That will, for example, this, not this, because so to have an access to the parent, you need to use super dot, and here it's already suggesting you, and in our case that will be drive, and let's say 60 miles, for example, right? And this is pretty much it for this one. Let's just set the name. You probably want to change the name. Set name. Oh, actually no, because we already have, it is public. Or we can do set name.
So here we're saying you added the method drive at 60 as a base unit?
Yep.
Or is it Go? What is Go? I didn't get Go.
So Go is just a method, and next from that will invoke this method from here, right?
Okay, so whenever you have like a inherited class, you have to have Go and add the methods that are not linked to that inherited class in Go.
No, so Go is just my method. It can be like drive fast. I don't know.
Ah, okay.
It just a method, another name. Yeah, and for example, to set name, this name equals name, and here in the constructor, what we can do is we pass in name, right? And we saying super dot set name with a name, something like that, right? So we basically now we have an access to everything we have in the car class. So let's test it. Oh, actually drive fast, so let me pass speed as well. So const I don't know, M5. Let's drive crazy, and we have new BMW class, and I'm passing the name, which is, I don't know, M5, right? So now console log M5. Let's go to the browser. Let's call super constructor. Yeah, sorry. As I remember, because I probably missed that. With super, it says must call super constructor intermediate class before accessing this derived class. Right. I think this equals, is it this equals super? Is it like that? Maybe Ricardo knows better. Not like that, definitely not like that. I'm trying to remember. Super JS. This is what happens when you're not doing that every day. Height width, great. You have constructor height, super, and lengths. Wait a second. Super, so we're extending, and then just super. Okay. Oh, right. So you have set, but this is what we're doing, right? Looks like what we're doing. Super log and B, which is from here. So why doesn't like it? Yeah, looks like we're doing absolutely the same. So what's going on? Let's call super constructor. Oh, right. Sorry. Super. You want to do this, I believe. Yeah. So you need to invoke super before in your in the constructor to make sure that you have an access to the super from here to have basically access to this class, to the parent class, to the inherited class, let's say. So yeah, you need to invoke this. Something like that. It's just a syntax. So super, and now you can use something from the super. Yeah, great. So now we have a name, we have engine size, and we have speed, right? So what we can do is to call M5 dot drive fast and pass, I don't know, 100 miles. So now if you refresh, you can see that its speed in your BMW is 100, right? Because and the speed value we have only here in the car, we don't have anything here. So you're basically extending this one, your BMW, with the generic class car, and this is how inheritance is working with classes. Does it make sense?
Yeah.
Is it like having creating an object and then an object inside of it, like a nested object?
Kind of, yeah. So, but again, classes are different because you can actually store data in them, right? And you can create different instances. So if I can create another car, and that will keep the separate memory place, and that you can refer to it like a, I don't know, const x6, and you can create a new BMW, right? And that will be completely separate, because with objects, with regular objects, you can't have different instances and referring to the same construction, because it just pointed to one place in the memory. But with classes, you create in like a blueprint, and every instance will have a separate place in the memory.
Okay.
So is it a bit like if you had the main item, if we're using another metaphor, is that the main item is a building, and then if you want to add an inheritance, you would have like the new class would be like I don't know, a tower, and then another one would be a school type, and then each would have like the same underlying kind of methods, but then they have their own specific little methods.
Yeah.
Okay, got it.
Yeah, exactly. Yeah. So because sometimes you have again, you have same properties, and you can create separate like BMW class with all these properties, and then I don't know, Range Rover with the same properties, and like Vauxhall or whatever, all these with the same properties, but you don't want to repeat yourself again and again and again and again. That is why you're creating this abstraction, like a generic thing, which you can reuse it across all your classes.
So if we use the BMW analogy, so would it be like, for example, if we have like options that are not on the main car? So if I don't know about like heating seats, for example.
Yeah.
Okay. Got it.
Yeah, exactly. Something specific, or like a body type coupe or something.
Cool. All right.
Yeah.
Yeah, that's very clear. Thank you.
Okay. Yeah. So, any other questions on that one? No.
Not for me, thank you.
Okay. Yeah. So basically, here we have another example that you have a person, and you can use person for nurse, and you can use person for celebrity, right? And again, this is as you said, that it's just generic saying that you can reuse for in different other classes to construct new classes. Yeah, great. And yeah, so now you can just call instantiate your class, and then just do whatever you want. Call your methods and get properties that you have inside these classes. Okay, so then the next step, probably the last step, for classes for today is inheritance. Oh no, we still have polymorphism. Yeah, okay, so two more things. Oh no, it is. Yeah, sorry. So inheritance and the polymorphism. Last thing is polymorphism. So for polymorphism, it's basically ability to create a property or an object that has more than one realization. And that means that all these concepts there, to be honest, it is tricky to explain probably. But imagine we have in our code examples, I've pushed like exercise. It's not exercise. I pushed the one more repo, which is like under 59, which is not exercise. It's just read with all these methods and all these patterns. And there we have an example about the shape. So you can create a shape class, and you can create different shapes like circle, triangle, rectangle, etc. Right? So you kind of, this polymorphism, so you can modify it, basically extend your circle class with the shape. So yeah, all classes which inherit from the same class can be used as the Z class, which is confusing. I understand that. But again, you just kind of using the one generic class for different purposes. And for shapes, it's like a probably common example that you have very different shapes, but you still have the generic class shape around that. And yeah, so here we have, let's say, birthday party, and we have happy birthday, and we have just birthday for the Sam. So here we can, because Sam is just a person, right? So new person, Sam, this is it. But we can use the same birthday party for class nurse, right? So this is completely different and not related to Sam class, but you're still reusing your person class, which is confusing. It just, yeah. I'm not sure that it makes sense. Does it?
So here we're saying that COVID nurse and person can both use the birthday party method, or
yeah,
it can be a parameter for a birthday party.
Yeah, exactly. So,
although COVID nurse is or is not a person, I didn't get that actually.
Yeah, so person and the generic as person, regular person, has been used to create instances of any person, but it also was used to create a nurse class. So now you can a COVID nurse, which extends, which is extended by person, as we had. Sorry, we had. Where was it? Is inheritance. Yeah, this one. So we are extending nurse with a person, right? And now we use person for different different classes. It's not because in the initial example we had like BMW, Vauxhall, Range Rover, so they kind of similar things, right? It's just you extending similar class of something, like it was all of them were cars, you had just different makes. That is why you have different other classes with some very specific things. But for example, nurse is not just a regular person, or celebrity is not a nurse. That is why this is polymorphism. So you can use person for nurse, you can use person for celebrity, you can use person for bus driver, etc. Because they are not related between each other, but they still have the common thing, which is person object, person class.
Okay, so things like birthday party, only the person attributes will be used for the birthday party function.
Yeah, because between
whatever specific to the nurse or to the celebrity.
Yeah, exactly.
Yeah.
So they are completely different, but still all of them still have birthday parties. That is why you have your birthday inside, like happy birthday inside the person, because no matter who they are, they still have birthday.
Okay, let me add an example, hoping to clarify a little bit more, Thomas. Let's say, for example, we have a class, human being, and within human being, all of human being have common stuff. For example, we can create a subclass called person that inherits elements from human beings, and we can also create a class called animal, which also inherit elements from human being. Now the properties of humans, a person and animals are different, but they have in common, for example, that they breathe, so that belongs to the human being, and also belongs to, the person and the animal inherit that from human being, but we also communicate. Now the communication is different. So we also have a communicate method that is an action that we do, but within animals, that action is different because animals, same as persons, we communicate, we talk, but the animals can bark if they are a dog, can meow if they're a cat. So that's how the polymorphism allows to have a similar action on their communicate. It's just that it changes from one animal to the other one, although we all inherited from human beings. So it's morphing from just communicate to barking, for example.
Yep.
Make sense?
Probably not. But yeah, you're right, Ricardo. But I found, I don't know, does it make sense for everyone?
Yeah, I think it does. I think that, yeah, I think it does. Yeah. The example you just raised, Ricardo, actually to me raises more questions. I thought because if we go back to the example of the nurse and celebrity and person, like, are we saying that some attributes of birthday just are changing for a nurse and then for a celebrity? I thought they would just be only the common denominator of all two that can be taken for a happy birthday.
Yeah,
maybe.
So as Ricardo said, that it can be changed
right.
from one to another. Yeah, so that is why you have something very generic that can be modified to something specific, depends on where you use it. But the structure is still the same.
Got it. Okay, so, I understand the concept, but then it's a bit different than what you are showing with birthday party, I guess.
Yeah, maybe you're right. Maybe we can redefine the examples.
The whole object-oriented programming, it's a complex paradigm that it's not easy to grasp when you read about it. You really need to get hands-on, doing some exercise until you actually see it. So it's one of those things, like the first time you heard of them, it's like, okay, yeah, I'm still not getting it, but let's see how it works. And eventually, when you see the code, you're gonna see like, oh, I see what this is doing now.
Yeah. Yeah. Again, I understand your feeling now, because when I heard about OP for the first time and all this polymorphism, etc., it was so confusing. Like, what the hell? Really.
Well, the reassuring bit is your intro, where you said you haven't seen it in the last few years. So
Yeah. Again, and for
That's
the
what
front end, again, 6 companies, and I haven't heard from any of my friends that they are actually using that as well. So yeah, and especially like JavaScript lately, they just try to move out from OP completely and just do functional programming, and like the React switched from class components to functional components, and like everything is in JavaScript looks like moving to just functional programming. So yeah, it like just nice to know and understand what's going on, but yeah, I'm not sure that for like, if you decide to build a project like a website platform or whatever, you don't need to use OP. And this is not something actually that, like, OP is just an approach. So you might achieve absolutely the same without OP by doing in other way, with functional programming, for example. So yeah, it just the philosophy, as I would say.
is that something that you may see in programs like Swift? You know, like the one for app development.
Yeah, so Java and I think Swift might be, no, Swift based on C#, right, or C++. But Java is like just object-oriented programming language, and Java is for Android programming.
Oh, for Android programming. Okay.
Yeah, I'm not sure. I think it's. Let me check that, because I don't know.
I mean, I saw the meme of one of your students saying it's a worse than death sentence, Java. So I thought, like, okay, maybe you don't want to
The
learn
Swift
Java.
is also very object oriented. It's what it's now used for the new language from Macintosh.
Yeah. Okay. Fair enough.
Yeah, because I did a very quick class, I think, on Swift, just as an intro, like on Udemy as a platform, and I remember kind of having some, like, they were mentioning some notions of object programming, so that's why I thought.
Yeah. Okay. So yeah, this is polymorphism, and we, as I said, exercise 59. We have it's not exercise actually, just a read with examples and all these concepts. So we have there we have like encapsulations, abstractions, reusability, inheritance, polymorphism, association, aggregation, and composition. You can read about that and have fun playing with it. So I want to say also, I was planning to for today to quickly show you how you can build similar things, but just with classes. Okay, so I want to create like a same saying, like I want to build a counter. So I will have like in each one. Let's start from 0. Class counter. And here we'll have the buttons, and here we will have button increment class increment decrement. Yeah. Okay, let me refresh the page. Beautiful. Great. So now we can actually create a class counter. And here we will have our constructor, and we will have this value equals 0, and we can increment method and here we want to have this value plus equal 1, and here we want to have decrement this value plus minus 1, right? So we have this counter class, and now what we can do is just find our element const counter element, right? So how can I find the counter?
How can I find?
Yeah, so I want to select this element.
The element, yeah.
Query select.
Query select.
Document query selector,
And then, yeah, I can't remember what it was. I think it was counter.
yeah, counter. Yep, found the counter. Next step, we want to find const button increment. BTN. Query selector, increment, and the same for decrement. Decrement. So now, basically, you have increment.
I think it's capital D that you put it on decrement.
Really? Yeah, thank you. Good spot. Thank you. So yeah, dot add event listener, right? So we add the event listener. We want to listen for a click. And what we want to do, and potentially here, to be honest, let me just move this to the very top. Because here, we can actually create another method, which will be like update counter element, right? And we will set to our counter element. How do we set the value?
The inner text or value.
Yeah, inner text is fine. Will be this value, right? And again, this one can be private because we don't want to do it separately. So now, when you increment, you can just do this forward. My gosh, this one update counter element.
Sorry, can you repeat again why you would do that private update counter L?
Because we don't want to make it, so we don't want to directly access the modification without actually changing the counter. So we want to modify our element only when we change the value of the counter.
Okay, so if you were making it public, you could actually just
I can hack.
Okay, got it. Like you could actually just manually update it.
Yes. Yeah, and the value will be different from what we see in the DOM.
Yeah, okay.
Right? So now, and same here, we just call this method. So now our decrement, we can call it abstraction, and this one is abstraction because we're doing two things for that purpose. So now increment button basically will be we want to initiate new class const my counter, and that will be new counter, and my counter here will be my counter dot increment, right? And for decrement will be
decrement.
This is it, right? So let's try. Refresh. Great. Must be an instance of class counter. Object. Which object? What's going on? Which one? Line 16.
16.
Ooh. What's going on? Counter element. Object must be an instance of class counter. Okay. Does it? Maybe it doesn't like this one. So this. Let me try. Maybe we are doing just one. So we have the element. So now we can actually modify the element. Maybe. No, still no. So object must be an instance of the class counter. Which object? Update counter element. But it is.
Do you need to return something maybe? No.
No. Okay, so if I remove this, I'm just wondering. Yeah, so same here. But why? It's not a function. What? What's going on? So this update counter element is not a function. What the heck? It is. We have it. What am I missing? What am I missing?
It's not a function more.
Wait a second. Do they want me?
This? Yeah.
Yeah. Yeah, it's not defined. What the heck? They just ruined my world. What's going on? Let me check this. Increment. This update is not a function. What it is? Okay, let me just console log. What is that? Undefined. Beautiful. What the heck? Am I blind? Am I missing something? Yeah. So it's not defined. Ooh. Is it because of the scope? It shouldn't be. I'm just thinking. Nah, definitely not. Maybe. Let me just quickly check this private method. JS. Not there. This. It might be silly. No. Right, method. Class. Let me check that. So we have here we can have private classes and static this. Yeah, so that should, I mean, initially that should work even with our private thing. What's going on? So if you go back, refresh, increment instance of the class counter. What is object? Let me check. What's that? Refresh, increment. Ooh, line 16. Right. What the heck? What's going on? Method. this, right? This private method. This is what we're doing. What the heck is going on here? And we definitely got there. When we click increment, we're doing this. I'm wondering, is it? No, it shouldn't be, but yeah, let me check. It is a class. So when you have a fat arrow function, you're basically referring to the parent. So that might, I mean, it shouldn't, but let's test it because it did work, right? Okay, yeah, fucking sake. Okay, yeah. So arrow function. Remember the scope with arrow function, the difference between regular function and arrow. That you need to, if you want to have an access to this, to actual this, you need to have an arrow function, because if you have a regular function, this refers to the function itself. So I'll show you if I get rid of this one.
And so you don't need to put the const before it then?
Sorry?
You don't need to put const increments?
No, because this is a part of the class, so you don't need to put const.
Okay.
And let me console log this, so you will see that. So on increment, let me just comment it out, refresh. So it's actually referring to the element I'm clicking here. So yeah, which is just, we just don't have a reference to the class. Let me just check that with, if I change it to function, good old function, and call increment, refresh. Yeah, so now we have a reference to the parent. And the difference is that here, if I change it to arrow function, I think we will break it again. No. So why? We need to have a wrapper. Because, okay, we need to have a wrapper for that, which is odd. Let me think. So if you put this directly without wrapper, this refers to the element. If we put the wrapper, this will refer to actual thing, so we can use our private classes, I think. Let me test it. Yeah, so now we can increment and decrement. So the question is why this one is referring. So yeah, do you see the difference? So if you have here like this, so this word, this, will refer to the element you're clicking on. But if you wrap it into an anonymous function, now when you call in this inside your counter, that will refer to actual class. Yeah, which is odd, to be honest. We still can use const this one, but yeah, so we need to have a wrapper around to have an actual reference. Right, sorry, I forgot to change this one. Yeah. So when if you want to use basically so the structure of the class here is correct. The only problem was here how you use this, where do you call it, and how do you call it. So you want to have, you want to wrap your methods into a function, into an anonymous function at least, so it will not keep the reference to the element you're listening. So you'll break the reference with the anonymous function. Yep. Trust me, you need it because you have an exercises about that. Because you need to, for this week exercises, you need to rebuild your multiple counters, but with classes. You will see that that will be easier than just the classes, than just the one that you built without classes. So that should work. Increment and decrement. Yeah. Pretty simple. And that is why you isolating the counter into one place, and you can work there. You can actually set, potentially, you can set like an element. Maybe even that might be better structured, this element equals element. And here you will change element, this element. So you can actually reuse your counter for different elements. And in this instance, you will pass your element, right? And you can create a counter for another element, and that will refer to that element. So you can reuse the same many times. So actually, let's do that. Let's actually do that. So we have event listeners, right? Same event listeners. And let me just add another counter too, for example. Let me check. We can actually create the whole counter inside. Let's do that in a second. So here I want to, my counter 2 will be counter 2, and we can pass that here. So this one now, we basically need to repeat this one, right? Which is not the really nice thing, because so we will update two things. We're not updating two things. Did we save counter? All right. Yeah, because we're not calling, right? So we need to call the same methods for this one. But what we can do, we can move like on init, we can add event listeners. So we can add our event listeners inside for buttons, for the selectors. And then you will have, I'm just thinking, because if you have a timer, I'm just thinking that if you have a timer, that will be in scope of one thing. That is why you can actually have your event listeners inside, because the timer will be the whole element, and there you will have the structure. So you can look for the things, for buttons, and listen for them. Yeah, that's probably it. I will not do that now. You will have fun with your exercises. This element. Yeah, so that still will work. And you just need to pass the element. Okay, questions please? No?
No questions. Apologies if I missed that. So the exercises you've put them on, right? On the
Yeah. So we have two exercises. First is just a basic, just creating classes, and the second is timers with OP. So you just recreate timers with OP.
Got it. Okay.
Yeah. And the next lesson will be about TypeScript and a bit more OP. So that will be on Wednesday with Thomas. So you will have some talk about TypeScript and why it is very helpful, because JavaScript is pretty messy. You might already notice that. Yeah. Okay. If you don't have any questions, then I would say that this is it for today.
When do you plan to put on the